Sometimes you need a fast local search engine without extra infrastructure. Tantivy gives Python a strong BM25 index with a very different trade-off from simpler search libraries. This is the setup you'll be able to run after this, which indexes documents with fields and returns top matches ranked by keyword relevance. I'm Professor Pi, teaching search and IR with simple Python. Search is a practical tool, not a toy. When you have a collection of articles, help pages, or logs and need quick relevant hits, you want relevance ranking that feels smart and returns useful results fast. Tantivy brings a compact disk-backed index and a BM25 scorer that often beats naive keyword filters. It runs locally, avoids a heavy server, and yields millisecond queries on small to medium corpora. At a high level, full-text search turns words into a fast lookup structure that knows which documents contain which tokens and how common those tokens are. BM25 boosts documents that contain the query words in informative places. That gives you ranked matches rather than an unordered list. The trade-off is less flexibility than vectors for semantic search, but usually far simpler and cheaper to run. We will build a tiny index, add a few documents, then demonstrate ranked queries, phrase matching, mandatory keywords, and a numeric filter combined with BM25. The code will be simple and local, so you can experiment with real text and see how relevance changes before you scale up. Now we create the index and load some documents. This snippet builds a tiny in-memory Tantivy index and ingests a few test documents. The variable SB is a schema builder that defines an unsigned ID field plus two stored text fields named title and body. The object IX is the Tantivy index created from the finished schema. The writer W accepts three small documents via writer add document, each with short readable content to keep the behavior obvious. A writer commit call finalizes the segment so the data becomes searchable. Finally, the variable N represents the number of documents just added. The printed docs indexed confirms that indexing succeeded and the index is ready to search. Next, we run a BM25 query to rank matches across title and body. This example performs a BM25 ranked query over the title and body fields using Tantivy's QueryParser and Searcher. The reader and searcher expose a point-in-time view of the committed index. The QueryParser is created with both fields, then parses the query string BM25 into a compiled query. The call s.search q3 retrieves the top 3 scored candidates according to Tantivy's default BM25. The IDF field handle is used to fetch the stored ID from the top-ranked document. The variable top score rounds the floating point BM25 score to 2 decimals. The printed top ID and score show which document BM25 considers most relevant for BM25. Now, try a phrase query to require exact word order and proximity. This code issues a phrase query in Tantivy to tighten matching with term proximity. The QueryParser turns the quoted string into a phrase query that requires the words BM25 and vex to appear adjacently in the same field. The searcher S executes the compiled query and returns scored results, but only documents containing the exact phrase will be included. Using IDF, the stored ID of the top match is retrieved to make the outcome obvious. The variable hits measures how many documents satisfied the strict phrase constraint. The printed ID and hit count reveal the precision benefit of phrase search for exact wording. Next, require that multiple keywords must all appear in a result. This snippet tightens relevance by requiring both terms using Tantivy's must operator. The QueryParser accepts the plus BM25 plus fast query, turning each plus prefix token into a mandatory clause. The Searcher S runs the query and returns only documents containing both BM25 and fast in the indexed fields. The IDF handle is used again to pull the stored ID from the top result, so we can see which document remains after applying the constraint. The variable hits reports how many candidates survive the stricter logic. The printed ID and count demonstrate improved precision by enforcing all keyword matches. Now combine ranking with a simple numeric filter to narrow results. This example blends lexical ranking with a structured constraint using Tantivy's QueryParser. The query BM25 and ID 2 to 3 combines BM25 scoring with a numeric range filter on the fast ID field, reducing the candidate set before scoring. The Searcher S executes the hybrid query and returns the best scoring match within the allowed ID interval. Using IDF, the stored identifier is read from the top hit, while top score shows the BM25 value rounded to 2 decimals. Tightening the numeric range typically cuts latency and avoids irrelevant segments. The printed ID and score confirm a filtered BM25 result that is both precise and efficient. In a real project, this pattern maps to a document store that holds metadata you can filter on, plus full text that you rank. Use the numeric filter for tenant IDs, dates, or status flags, and let BM25 rank the remaining candidates. Recap: what it is, when to use it, one caveat. Tantivy in Python gives you a local BM25 search index that returns ranked text matches. Use it when you want fast, relevance-ranked queries without deploying a heavy search service. Caveat: lexical BM25 finds keyword relevance, not meaning. It will miss queries that need deep semantic matching. Next step: tune the BM25 parameters K1 and B to change how term frequency and document length affect scores, and observe how results reorder. If short practical IR helps your projects, subscribe and watch the IR videos.